Good evening, guys. In the last session, we started our discussion related to what is a Docker and why we need to go for a Docker and what is the benefit we are getting with the Docker. So in the yesterday session, we discussed that when we are developing one application, three layers will be available in the application. Front end will be available, back end will be available, and database will be available. Front end will be developed by using one technology. Back end will be developed by using another technology. Okay, and database will be available as a separate thing. So when we are having like this client server architecture and all, front end browser side front end will be loaded, and in the back end server side our application will be executed. And for our application, one database is also required in order to store the data. So if you want to run that application, we need to install all these softwares in the machine. So if you have multiple machines to run your application, all these softwares you need to install in all these machines, that will take a lot of time, and there is a chance of doing the mistake also. To overcome that problem, we are going to use a concept called Docker concept. So what is this Docker and how this Docker is going to help us? Docker is a containerization software which is used to simplify our application execution process in any machine. Docker is a free and open source software. We are using the Docker for containerization. So what is the main benefit of using this Docker? The main benefit of using this Docker is whatever the dependencies that are required to run the application, whatever the dependencies are required to run the application, instead of we are downloading and configuring those dependencies, Docker will take care of those dependencies. So I want to run my application in 100 machines. You no need to install the softwares in all the 100 machines. Docker will take care of that. So that is called containerization concept. Okay. Now here with the help of Docker, we can make our application portable. That means you can run the application in the Windows machine, Linux machine, Mac machine. You can run your application in any machine without bothering about underlying softwares available in the machine. Which operating system, which version of Java, which version of Python, which version of Angular, which version of database, all these things you no need to worry. Docker will take care of that. Okay, now in order to work with the Docker, we need to understand Docker architecture. So what is Docker architecture? Let us understand this. So look at this diagram, guys. So this is Docker architecture. Okay, so if you want to work with the Docker, then we should know about this architecture. Are you able to see my image, guys? Are you able to
Yes,
see the image?
Yes, yes.
yes,
Yes,
sir.
yes, yes.
Yes. So this is Docker architecture, how Docker is going to execute. We understood without a Docker, deploying the application in the multiple machines is challenging task, because for every application, some dependencies, some softwares are required. So instead of we are downloading those softwares manually, Docker will take care of those dependencies. Fine. So that's why everyone is using containerization concept in the real time to run the applications. So Docker is a containerization software. With the help of Docker, we can run our application in any machine. You no need to bother about dependencies to run your application. Docker will download those dependencies. Fine. How we are going to work with this Docker? This is the Docker architecture. When we are talking about Docker architecture, we need to know about Docker file. We need to know about Docker file. Then we should know about Docker image. Then we should know about Docker container. Then we should know about Docker registry. Okay, before this container, we can say Docker registry is available, and then Docker container will be available. So when we are working with Docker, you should know about these four components. What is Docker file? What is Docker image? What is Docker registry? Then what is Docker container? So this Docker architecture we should know. Docker file, Docker image, Docker registry, and Docker container. So what is this Docker file here? So here Docker file is used to specify what dependencies are required for our application. So which softwares are required to run our application. So I want Java 17, Angular 16, Tomcat 9 version, database 8.5 version. What dependencies are required, which version dependencies are required, that we need to inform to the Docker, then Docker will download those dependencies. So to specify application dependencies, we are going to use this Docker file. Okay, so Docker file is used to specify where is our application code and what dependencies required to run our application. Okay, Docker file is used to specify where is the code of our application, and to run that code, what dependencies are required. Those things we are going to specify in the Docker file. Now, once the Docker file is available, so it is our responsibility to write the Docker file. What dependencies are required for our application? As discussed yesterday, for our application execution, this is the technology stack we need. Angular 16, Java 17, database 8.5, Tomcat 9.0. These all softwares are required to run my application. I will tell to Docker this to download all these dependencies. Wherever I'm going to run my application, in which machine I'm going to run my application, in that machine, all these softwares should be downloaded. So I need to inform to the Docker, these are the dependencies for our application. So that's where we are going to use Docker file. What is the purpose of Docker file? Docker file is used to specify where is our application code and what dependencies are required for our application execution. Where is our application code and what dependencies are required for our application execution. So once the Docker file is available, using Docker file, we will build a Docker image. Using Docker file, we will build Docker image. So if you observe, once the Docker file is available, in the Docker file, we will specify what dependencies are required. Using that Docker file, we will build Docker image. What is a Docker image? Docker image nothing but it is the combination of application code plus application dependencies. What is the code of our application? To run that application, what are the dependencies are required that we are going to package as a image. Image nothing but which contains the code of the application and the dependencies of the application. Are you able to understand what is the Docker file here? Docker file is used to specify what dependencies are required to run our application. Docker file is used to specify what dependencies are required to run our application. And where is the code? What dependencies are required will configure in the Docker file. Then by using this Docker file, we are going to build Docker image. What will be there in the Docker image? Docker image contains application code plus application dependencies. Then Docker registry. Docker registry is used to store. The Docker images. Using Docker file, we will build Docker image. Docker image is a package. Docker image is a package which contains application code, and application dependencies for execution. Code is required, dependencies are required. The code and dependencies we are going to keep. Whatever the code is required, whatever the dependencies are required, that we are going to package by using Docker image. So once the Docker image is available, then Docker registry will be available. Docker registry is used to store Docker images. So in my project, so there are multiple microservices available. For every microservice, one Docker image is created. To store all the Docker images, we need one registry, that is Docker registry. Docker registry is used to store the Docker images. So we can make our image as a public as a private. Public images anybody can download and they can run the image. Once the Docker image is available, that Docker image you can run in any machine. So you can run the Docker image in the Windows machine, in the Linux machine, in the Mac machine also. So in this image, code is available, dependencies available. So in the file, we will specify where is the code, what is the location of the code, where is the jar, where is the var, that we will specify the location of the code and what dependencies required for the code execution, we will configure in the Docker file. Then when we build, the Docker image will be created. In the image, code plus dependencies will be available. Here we will specify what dependencies are required. Then Docker will download those dependencies, will keep in the Docker image. Now, I want to use the Docker image in future also. Then you can store the Docker images in the Docker Hub. Docker Hub is called as Docker registry. Once the Docker image is available, then you can run the image. When you run the Docker image, Docker container will be created. Container is nothing but one virtual machine. Container nothing but one virtual machine. Once the Docker image is available, you can run that Docker image in any machine. So in the Windows, in the Linux, in the Mac. Sir, do I need to download the softwares to run the application now? No. You just need to run the Docker image. When you run the Docker image, Docker container will be created. Inside the container, your application will be executed. Okay. Docker registry is used to store Docker images. Docker images. When we run the Docker image, then Docker container will be created. Docker container will be created. Sir, what is this Docker container? Docker container is a virtual machine. Docker container is a Linux virtual machine. Whatever the container you are creating, that means your application will be executing in one Linux virtual machine. Who will create that virtual machine? Docker will create the virtual machine to run your application. In that virtual machine, Docker will install all the required dependencies for your application. Docker container is a Linux virtual machine. Docker container is a Linux virtual machine. Docker container is used to run our application. When we run the Docker image, container will be created. Container is a virtual machine. Inside a Docker container, our application will be executed. Inside the container. So now what we are going to do? I'm going to take one machine. This can be Windows machine or this can be Linux machine. So I'm going to take one machine. So inside this machine, I'm going to install Docker software. This is one machine, guys. Inside this machine, I'm going to install Docker software, Docker engine. If you want to run Docker images, then we are going to install Docker engine in our machine. Docker software we can download and we can install. That is free of cost. Once the Docker engine is available, then you can download the Docker images from the Docker Hub. Docker Hub is available. Inside the Docker Hub, Docker images will be available. Okay. So from this Docker Hub, you can download the Docker image. Okay. So here, multiple Docker images you can download. You can pull the Docker images. You can download the Docker images. Now, once the Docker image is available in our system, then we can run the Docker image. When we run the Docker image, Docker containers will be created. So inside one machine, we can run multiple containers also. Every container is a virtual machine. Container 1, container 2, and container 3. Here, I'm running Docker images. When we run the Docker images, then Docker containers will be created. Every container is a virtual machine. So here, our machine is available. Inside the machine, we downloaded the Docker software installed. That is called a Docker engine. Once the Docker engine is available, you can create a Docker image on your own by using Docker file. Suppose if the Docker images are already available in the Docker Hub, some public images, you can download the Docker images and you can run the Docker image. When you run the Docker image, container will be created. What is a container? Container is a virtual machine. Inside the container, our application will be executed. So this is Docker architecture. So once the image is available, you can run that image in any machine. So in that machine, the softwares are installed or not, that's not required. Only thing that you need to do, you need to install the Docker software in your machine, then you run the Docker image. In the image, code is available, dependencies available. Then it will run the application inside a container. Container is a virtual machine. Inside one computer, you can run multiple containers also at a time. So if I run 3 images, then 3 containers will be created. So this is one virtual machine, this is another virtual machine, this is another virtual machine. So total there are 3 containers available, nothing but 3 virtual machines are available. Now, so here, if we talk about this one, host operating system, guest operating system concept comes into picture. This is my computer, guys. So my computer is called as a host operating system. Excuse me. I'm taking one computer. I'm taking one computer. In my computer, one operating system is available, which is called host operating system. Then in this host operating system, I'm going to install Docker software, which is also called as Docker engine. Once the Docker engine is available in our machine, then you can create the Docker images, Docker image 1, image 2, and image 3, multiple images you can create. You can create images by using Docker file. If you don't have a Docker file, then you can download the images from the Docker registry. Docker registry is a place where the Docker images are stored. Image 1, image 2, image 3. You can create by using Docker file, or you can download the images from the Docker Hub. Once the images are available, when you run the Docker image, then Docker container will be created. So for the image 1, I'm creating container 1. By using this image, we created this container. Similarly, by using this image, we created this container. By using this image, we created a container. So by using image, we can run the containers. What will be there inside the container? Inside the container, our application will be executed. So this is host operating system, nothing but this is my computer. Host operating system, this is my computer, my machine. In my machine, one operating system is available. It can be Windows or Linux because Docker supports multiple platforms. In the Windows machine also, in the Linux machine also, you can run the Docker software. Now, in my machine, host OS is available. What is this host OS? It can be Windows or Linux. Then in this machine, I have installed Docker software. In this machine, I have installed Docker software. By using this Docker software, I can create the images. By using the images, I can create the container. Now finally, where our application will be executed? Our application will be executed in the host operating system, or our application will be executed in the container system.
In the container
When we
system.
run the image, application will be executed in our system, or application will be executed in the container.
The container.
Application will be executed in the container. Application will be executed in the container. Are you clear?
Sir, one doubt.
Yes, sir.
Application will be executed in the container. What is a container, guys? What do you mean by container here?
Virtual machine. One virtual
Container
machine.
is nothing but a virtual machine.
Sir,
Whenever your
sir, one
application
doubt.
is running in the container, wait, sir, I will take your doubts. Okay, so give me some time, I will take your doubts. So here, container is running. Container is nothing but it is one Linux machine. Whatever the container we are creating by using Docker, that container is a Linux machine, guys. That container is a Linux virtual machine. So we have one machine. In that machine, we installed Docker in the host operating system. Once the Docker is installed, by using Docker, you can create the Docker images. By using the Docker images, you can create the Docker container. Now, inside the container, our application will be executed. That is the process. Now, so we are trying to understand what is Docker and what is Docker architecture. Docker is a free and open source software. It is not paid, guys. Anybody can download and anybody can use this Docker software. This Docker software is used for containerization. What is the meaning of containerization? Containerization means packaging application code and application dependencies for the execution. That is called containerization. What is a containerization? Containerization means packaging application code plus application dependencies as single unit for execution. Containerization is nothing but packaging application code plus application dependencies as single unit for the execution is called as containerization. With the help of Docker, we can run our application. With the help of Docker, we can run our application in any machine. Why? Because the Docker image is available. Once the image is available, you can run that image in any, you can download the image, you can run that image in any machine. Your application is portable now. Where is your application? Where is your application dependencies? Everything available in the image. Wherever you want to run this image, you can download the image from the Docker Hub and you can run the image. When you run the image, container will be created. Container nothing but one box. That is a virtual machine. That is a Linux machine. What about the softwares required? The Docker will take care of it. Already they are available in the image. We are running the image. When we run the image, container will be created. Sir, where I can run the image? In any machine you can run the image. There is no rule for that. In Windows you can run. In the Linux you can run. In the Mac also you can run. But what is required to run the image? To run the image, in your machine, Docker software should be installed. That's it. So now if you observe, if I want to run my application, in a computer, then I need to install all these softwares. In one machine, that is okay. If I have 10 machines, I need to install all these 10 softwares all these softwares in the 10 machines to run the application. That is difficult. So that's why what I will do, I will create a Docker file and I will specify the dependencies required for my application. I will package my application and my application dependencies as an image. That image I will store in the Docker Hub. Once the image is stored in the Docker Hub, then I can download that image and I will run the image in this machine. I will run the image in this machine. I will run the image here. I will run the image here. What is there in the image? Code is available. Dependency is also available. The Docker image will run in all the 10 machines. To run the Docker image in all the 10 machines, what I need to do? In all these machines, we will install the Docker engine. So in this machine, I will install the Docker. In this machine, I will install the Docker. Here Docker, here Docker. In all these machines, I will install the Docker. By using the Docker, I will download the Docker image. I will run the Docker image. That is called containerization. Packaging application code and application dependencies as a single unit for the execution is called containerization. What is the advantage? Our application we can run in any machine without bothering about the dependencies. Why we are not bothering about the dependencies? Already Docker image is created. What is there in the Docker image? Code is available, dependencies available. How Docker will know what dependencies are required? We are specifying in the Docker file. What is the Docker file? It is input for the Docker to create the Docker image. How many images we can create? Any number. Where we will store the images? In the Docker Hub. That is called Docker registry. Once the image is available, we can download the image from the Docker Hub. We can run the Docker image. When we run the Docker image, what will happen? Docker container will be created. What is a container? Container is a Linux machine. Inside the container, our application will run. What about the dependencies of our application? Docker will install them in the container. You got my point? What is the containerization concept now? All of you able to understand?
Yes, sir.
Yeah.
Yes, sir.
Yes, sir.
Very good.
Hello.
Yes, sir.
So this container is a virtual machine. So it will be running in another virtual machine. Like if it's a Mac virtual machine or a Windows virtual machine, the Docker image will be turned into a container, which is another virtual machine running in another virtual machine. Is that correct? Okay. Thank you.
Sir,
Very good.
We need
So,
to install Linux, sir,
So,
application.
so these
Sorry?
VMs are running on the Citrix platform or where, sir?
sorry, sir.
These containers
Mhm.
will be run on some platform, right? Like we use a Citrix or some kind of other platform
You
where
can run the container in any machine, Windows, Linux, Mac, any computer. In any computer you can run. No need of Citrix platform and all that stuff. In any machine, in normal computer also you can run.
Sir,
okay.
through this Docker file, we suppose we have to install. We do not have Java 17 in our system. So if we write in Docker file, then automatically it will be there. No need to install Java 17 or any Java.
No need of that. First of all, the Docker container is not related to your machine. There is no relation between your machine and Docker container. Container is a separate machine. So if you see here in the diagram, your machine is available. The Docker container is having any relationship with your machine, or it is not related with your machine?
Related.
No relation, sir.
Not related. In your machine, what softwares are available, that does not matter. Only the Docker software should be available in your machine. Container will be created. For your application, Java required, .NET required, Python required, Node required, anything. Those softwares will be installed in your host operating system. The softwares will be installed in the container machine. Application dependencies will be installed in our computer, or they will be installed in the container machine.
In the container machine.
Container, sir.
Yes, they will be installed in the container machine. Now, for my application, Java is required. For my application, Angular is required. Java is required. MySQL database required. Tomcat required. So when I run the Docker image, so these softwares will be installed in our computer. These softwares will be installed in the container computer.
Container company.
Whatever the dependencies we are specifying, those dependencies will be installed in the container, not in our machine. In our machine, Java, .NET, nothing is available. Only Docker is available. What softwares are required for your application, they will be installed in the container machine here.
Sir, can we
Sir.
deploy multiple images in one container?
Sorry?
Can we deploy multiple images in one container?
Can we deploy multiple images in one container? Your question is wrong. By using one image, we can create multiple containers. That is what you are expecting?
No, sir.
If you have one image, by using image, you can create the containers. What you are asking, can we deploy multiple images in one container? How to deploy, how you will deploy multiple images in one container? What is the meaning of that? I did not understand. Could you please elaborate your question?
Suppose, sir, we created multiple images, correct?
He is asking one image is one port number. Take
Port
another
number I am not talking about. Port number I will explain later. Forget about it.
Okay, sir. What the difference between physical machine and virtual machine?
Physical machine means you can see the machine, you can touch your machine, you can on, you can off. Virtual machine means you can't see that.
Okay.
So how
Whatever
many?
the laptop you are using, that is a physical machine.
Okay. I have.
Container, how will create, sir? I'm asking how to create containers means.
How to create?
Containers means.
When you run the image, it will create the container.
How to create the image? How to create the container by using image?
Okay.
That you will understand in the practical class. Today I am explaining architecture. How to create image? How to create a container? Some commands will be available. That is the next topic.
Okay, sir. Based on one image, we created one container, correct?
Based on one image, you can create multiple containers also. It's up to you. I have one image. By using that image, I can create multiple containers also. One, two, many. That is possible.
Okay.
Sir?
It means.
Sir, how it is possible, sir? See, one image, multiple containers. How it is possible?
In the practical class,
See, one image means we have a code and dependencies. Okay.
Hmm.
Container means our application is running.
Hmm.
So
I-
I have a one means it is application. One application, that particular application related dependencies available in the image. The application is running in the container.
Can you
But
run
multiple, how it is?
Listen. By using what you have one application, can you run your application in multiple machines? One application, can you run in multiple machines or not?
Yes.
Yes,
In
sir.
the same way.
Yeah, yes.
So here the image is nothing but one template. Through the template, we can able to create a multiple containers.
Yes, every container will so by using one image, I created 3 containers. Every container is one machine. Your application will run in the 3 machines. The same application will run in the 3 machines.
Okay.
Like this, so how many containers can able to launch in the one physical machine or else virtual machine?
That depends on your machine configuration. So you can create 100,000. There is no limit. As long as your system supporting with respect to memory and space and all, then you can create n number of containers. There is no limit.
That is depending upon the hardware resources. Am I right?
Yes.
Okay.
The space which is available, the memory which is available, the processing speed that is supporting, based on that you can create n number of containers. And remember, in the real time, no application will run in one single container. In the real time, every application will run in the multiple containers for the load balancing. If you run your application in one container, then all the requests will come to one container, then your container will crash. So that's why in the real time, for every application, multiple containers will be available. That is called load balancing. Sir, how to create multiple containers? How to increase the containers? How to decrease the containers? That's where Kubernetes comes into picture. Okay, in the real time, we don't create the container manually by using the image. We will tell to Kubernetes, hey Kubernetes, this is my Docker image. For this Docker image, create 10 containers. Kubernetes will create the 10 containers. I will tell to Kubernetes, hey Kubernetes, 10 containers are not sufficient, increase to 20 containers. Then Kubernetes will increase from 10 to 20. Hey Kubernetes, 20 is not required, decrease to 15. Then Kubernetes will delete 5 containers, will keep the 15 containers. That is called orchestration. Containers will be managed by Kubernetes. Got my point?
One more
Sir,
question.
I have one
So,
question.
Yeah, please go ahead.
Sir, as I've understood, Docker will do the configuration and Docker will pull out that, download the dependencies which we have mentioned. So similar way we have POM, right, in the application.
No. Yeah,
So yeah,
Nisha. No,
yes.
yeah, I will clarify your point here. Good question. Whatever the Maven is available, Maven will download the dependencies. Those are called as the libraries. Maven will download Spring Boot. Maven will download JPA dependency. Maven will download JUnit dependency. Those are called libraries required for the application. Those libraries will be downloaded by Maven. Here, when I'm talking about a dependency in the Docker, so let me tell you with the diagram. Now, so you're from Java background. So
Yeah, yes,
whenever we are
yes.
developing one Java application, so in order to develop this Java application, we need some libraries. So what libraries are required? I need Spring Boot library, okay, and I need a Kafka library. I need a JUnit library. I need a Jackson library, and I need some Hibernate library. These are called as, when we are talking about Maven, these are called as dependencies. But when we are talking about Java, Docker, these things are called as libraries. Now, in order to develop this application, I need these libraries. Who will download these libraries for our application? Maven will download these libraries for the application. That is fine. Okay. Now, in order to run this application, I need dependencies. What dependencies? Java 17 version is required. Okay. And I need MySQL Server 8.5 is required. Okay. And I need Angular 16 version, software which are required. And I need Tomcat Server 9.0. So for the application development, libraries are required. For application execution, these are the software dependencies. There is a difference. Software dependencies and these are called libraries.
Jars. Okay.
Library is nothing but jar files which are
Jar.
required. Libraries will be downloaded by Maven. Maven cannot download MySQL database. Maven cannot download Tomcat server. Maven cannot download Java 17 version. Are you getting my point?
Yeah.
Right. So when you are doing the development, for your project development purpose, whatever the libraries are required, those libraries we are going to specify in the pom.xml. Maven project will contain a pom.xml. When you specify libraries in the pom.xml, Maven will download those libraries and Maven will add to the project build path. Now I am talking about project execution. I'm talking about the project deployment. In order to deploy this project, I need these software, Java, MySQL, Angular, Tomcat. So where we will specify these software dependencies? Software dependencies we will specify in the Docker file. Pom.xml is different, Docker file is different. Pom.xml to configure libraries. Docker file is used to configure software
Yes.
dependencies to run the application. Now, what will happen? By using this Docker file, we will specify these are the dependencies required. Now, with the help of this Docker file and with this code, application Java code is available. Java application code is available. And these are the dependencies. By using these dependencies and by using this Java code, by using this Java libraries, the Docker is going to create one Docker image. Your image is a package. In your image, dependencies will be available, application code will be available, application libraries will be available. Whatever the Docker image is available, this Docker image we are going to store into one registry. That registry is called as a Docker Hub. Once the Docker image is available in the Docker Hub, anybody can download the Docker image. Here, we will push the Docker image into Docker Hub. The people who want the image, they will pull the Docker image from the Docker Hub. Once the image is pulled from the Docker Hub, then you can run the image. Once you run the Docker image, then what will happen? From this Docker image, you can create a Docker container. What is the meaning of a container? Container is a machine. Inside that machine, your application will execute. Got my point?
Yes, sir.
Good.
So dependencies in the
Hello?
sense, is it a software or only it tells only the dependencies?
Dependencies means software, sir. Basically, when I'm talking about the dependencies of the application, these are softwares.
So
What are the
software will be
softwares?
loaded into the Docker image, sir?
Yes, sir. Softwares will be loaded into the Docker image. As I told you, Docker image is the combination of code plus dependencies. Libraries are different, dependencies are different.
So basically, we can say, right? I mean, pom.xml is help for building the Java application, and dependency are made for running the application.
Yes, sir. Correct. Libraries are used for the development, dependencies are used for the execution.
And sir, the image which we create using Docker, is it possible to update that image?
Yes, sir. You can recreate the image and you can update it also. When the code is modified, then you need to recreate the image.
Okay, but the already created image we cannot modify.
No, you need to recreate the image.
Okay.
Once the image is created, you can't modify. If you make any changes to, suppose, for example, today morning 9 o'clock, I created a Docker image. Then after I created a Docker image and I created a Docker container. My application is running inside the container. Container is nothing but a box. Then after that, there is some code change happened in our application. Okay. When the code is changed in our application, then what will happen? Again, I need to recreate the Docker image. Then I will run the Docker image again. Then I need to recreate the container. It is called redeployment. Whenever the code is changed, you build the new image, you run the image, you create the new container.
The size of the Docker image would be bit high.
Yeah,
right?
it will be, sometimes it will be in the MBs, sometimes it will go in the GBs also. That is also an interview question. How to compress the Docker image size.
Because it actually has all the softwares.
Yes, correct, sir.
Okay.
Images are heavyweight.
Heavyweight, yeah.
Because softwares also will be part of the image only, no?
Correct.
So
So
when
because of this image
Hello, sir.
only, because of this image only, our application is becoming portable. What is the meaning of a portable?
It can run in any of the systems.
Yes.
operating systems.
You can run in any computer. Now, do you need to, suppose I want to run my application in 10 computers. Okay, 10 different machines I have. I want to run my application in the 10 computers. Do I need to install all these softwares in the 10 computers, or these softwares will be already part of the image?
Already part of the image.
Yes, that's why you can run your application in any machine. You don't need to bother about which softwares we need to install, which version of the software we need to install to run the application. That we no need to bother about that concept if you are using containerization in the project.
Got it, sir.
So this image
Can you scroll down?
container.
Can you scroll down that image? In the last one, whatever you have shown, the Java code and all.
Yes, sir, I will come to
Can
that
you
one.
scroll down? So as a developer, we are doing the coding. Okay, what are the libraries required? So those are we are downloading from the Maven and we are building the code. After that, this Docker image and Docker Hub and these dependency softwares, as a developer, we have to do the coding, or it will be DevOps will take care.
Now, earlier, 3-4 years back, the Docker file creation, image execution, only operations team used to do 3-4 years back. But now developers also doing the same thing. Developers also should do this. Developers also should know this process. In some companies, sir, here Docker file is available. What is the purpose of Docker file, guys?
For
You have
creating
a
Docker
code
image.
and
Code and creating the Docker image.
To
Dependency.
create the container.
What is the purpose of Docker file?
To create the image. Docker image.
Docker file is used to
build a Docker image. To build a Docker image.
Docker file is used to create the Docker image. What will be there in the Docker file?
Application code and dependencies.
Where is the application?
All the
Code and dependencies are there in Docker file.
Where is the code is available and where
Docker
the dependency, what dependencies are required, we need to specify. How to write the Docker file? Who will write the Docker file? That is the question. Earlier, as I told you, 3-4 years back, only DevOps team used to write the Docker file. But today, in some projects, developers are responsible to write the Docker file. In the interview, they will ask you. Suppose if you are a Python developer, if you go for the Python interview, they will ask a question. Can you write a Docker file to execute Python application in the Docker container? Suppose you are from the Java background, they will ask you, I want to execute Spring Boot application by using Docker. Can you write the Docker file for that? That is the interview question. Even when I'm taking interviews in my company for the developers, I will ask that question. So I have a Spring Boot application which requires MySQL database and which requires MySQL database and Kafka. So could you please write a Docker file to run this application? Suppose whenever DevOps engineer comes for the interview, when I take an interview for the DevOps engineer, I will ask a question. Boss, I have a 3-tier application. I have database requirement. I have Java requirement. I have Angular requirement. So I have a Spring Boot application, Angular application, MySQL database. I want to execute by using Docker. Could you please write the Docker file for that? So both developers should know, DevOps engineers also should know how to work with the Docker. So now in this batch, out of this 107 people, I think 50 plus people are from the development background only. Yes or no? How many of you from the development background?
Yes, sir.
Yes. So why, as a development background guy, why you are coming for the Docker? Why? Because when you attend the interview, they are asking questions on the Docker. When you are already working in the project, your project is using Docker. That's why you are learning the Docker. So I told you in the yesterday session, both the developers as well as the DevOps people should know complete Docker concept, because in the industry nowadays, 99.999% of the projects are running based on the containerization only. You will not go and install all the softwares and you will not run the application manually. Completely containerization concept. For every project, Docker file will be available. In that Docker file, we will specify where is our application code and what dependencies are required. By using that Docker file, we will build the Docker image. By using that Docker image, we will create the container. Our application will run in the container. That is called containerization. What is the benefit with this containerization concept? What is the benefit we are getting with the containerization concept now?
We don't need
multiple
to.
deployments.
Application is
Level
The
loosely
application.
coupled
No
with the-
dependencies.
Application is loosely coupled with the machine. Yes or no? Application is loosely coupled with the machine. Why application is loosely coupled with the machine? For your application execution, what all the dependencies are required, you no need to download and install. You just run the image. Container will take care of it. What is a container? Container is another virtual machine. In your machine, one container machine will run. In that container, all the dependencies and your code will execute. Container means our application. Now look at the diagram. Docker architecture.
While deploying, it can be these containers can be deployed in multi-platforms also, like same one simultaneously. Like
Yeah, I told you that, right? If you see the diagram,
Azure or
container is running in Mac, container running in the Windows.
no,
container running
not
in
like
the
that. Platform is the cloud platforms like Azure, AWS.
Yeah, AWS.
Container,
And,
you can, so
Docker image.
listen. When you go for
Kubernetes.
Azure, when you go for Azure, when you go for AWS, when you go for GCP, how you will run? In the Azure or in the GCP or AWS, there you will take one machine only, right?
Yeah. No. Like when you deploy these containers, it will be only for the one platform, or it gets
No, multi-platform.
Multi-platform.
It supports multi-platform. You can run in any machine.
But this image is created in the Docker application software or website.
Yes, the only thing that you need is Docker software in your machine. By using that software, you can build the Docker image. Once the image is available, you can run that image in any machine, in any platform.
Okay. Thank you.
Sir, here I have one question. So, AWS or cloud or Azure also, there also one virtual machine required to run that application,
Yes.
right?
In that virtual machine, we will create another virtual machine, that is container.
Yeah, okay. So here my question is, for example, there is a CI/CD pipeline, GitLab pipeline. How this is in while running continuous integration, continuous deployment, right? How these containers will be using the CI/CD, sir?
Yesterday I have shown you the flow, right? In the CI/CD pipeline also, whenever there is a code change or whenever you run a CI/CD pipeline, what will happen is, this is the flow. Jenkins will take the code from the developers will push the code to the GitHub. Then Jenkins will take that code. Jenkins will build that code by using Maven. Then Jenkins will create the Docker image for you. Okay.
Is it like is it Jenkins? What about that GitLab, sir? It is same like GitLab also?
In the GitLab also same. In the GitLab also will write the script to create a Docker image. Whatever the code is available, you will take that code, you will build that code, and you will build the Docker image by using GitLab pipeline.
Instead of Jenkins, we can use GitLab also, right?
GitLab pipelines also.
Just
we can use.
okay.
Yes.
Okay, sir.
This is the flow. So wherever your containerization concept, so finally you need to build the Docker image. Whether you will create the Docker image manually or you will take the help of the Jenkins to create the Docker image, whether you will take the help of GitLab pipeline to create the Docker image, that is your requirement. Finally, Docker image should be created. Once the image is created, then you can run the image anywhere.
Okay, sir.
Yeah. Fine. Good.
Thank
so
you, sir.
we understood theoretically. So as of now, only theory we understood, not practicals, guys. So once we do the practicals, then you will get the better clarity of it. Okay. Good. So now, can you please quickly answer my questions? Anyone can answer. What is Docker?
Docker is a containerization software.
Yes. What is the meaning of containerization?
Virtual machine.
The process of packaging our application code plus dependency as a single unit is called Docker containerization.
Containerization, nothing but packaging our application code and
Require dependencies to execute the application.
Yes. What is the meaning of application dependencies?
Means the software need to run the application.
To run the application, we need to some dependencies.
The softwares that
To
are
run our
application
libraries.
called dependencies. What is the difference between dependencies and libraries, guys?
Libraries downloaded by Maven. And dependencies downloaded by Docker to run our application.
Right. Libraries, nothing but the dependencies which are required for application development. Who will download the dependencies?
Maven.
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 Who will download the libraries Maven? Who will download
Libraries
the
Maven.
Docker.
Application libraries will be downloaded by Maven. Application dependencies will be downloaded by Docker. Okay.
Docker.
Now, could you please tell me what is the meaning of Docker file?
Docker file, they contain the application code plus
Docker file is used to build a Docker image.
Dependencies.
Basic code
Docker
and what
file
dependency.
is used to
Docker file is
specify
to build
where
the
is
Docker
our
image.
application code and what are the dependencies required for application execution. That we will specify in the Docker file. Who will write the Docker file in the project?
developer, some
Developer as DevOps.
Either developer can
Developers.
write it or
Details depends upon the our project. Yeah.
either developer can write or DevOps engineer can write. Nowadays, mostly developers are writing the Docker files. Okay. So once the Docker file is available, using the Docker file, we will create a Docker image. So what will be there in the image?
Docker image is the
Application
package.
code plus
package.
dependencies.
contain the
Docker
required
image will contain
Combination of application
Docker
code plus
image will
dependencies.
contain application code plus application dependencies. So where we will store the Docker images for future reference?
Docker hub or Docker registry.
Docker
registry.
Yes. Docker images will be stored into Docker Hub. Docker Hub is called as Docker registry. Once the Docker image is available, we can download that image in any machine and we can run that image in any machine. What will happen when we run the Docker image?
Container is created where application is executed.
When we run the Docker image, Docker container will be created. So what is the meaning of container?
Is a
Application is
virtual
executed.
machine to run the application.
Container
virtual
is a
machine.
virtual machine. That is a Linux virtual machine, guys. Every container is a Linux virtual machine. In that virtual machine, our application will be executed. So dependencies will be installed in our computer or dependencies will be installed in the container machine.
In the container.
machine.
Container machines.
In the container machine. So currently, so if you see in my machine, OS is available, Docker is installed, images are created, containers are created. Is there any relation between container and my machine?
No, sir.
No, it is
There is no relation between container and our machine. Okay. Now, people want to access the application. Application is running in our machine or application is running in the container machine?
Container.
Container machine. Container machine.
Application, our machine is available. Inside the machine, Docker is available. Using the Docker, we downloaded the image. We created the image. Using the image, we created the container. So finally, our application is running inside the container like this. Our application is running inside the container. Once the Docker image is available, by using one Docker image, we can create multiple containers. One image does not mean only one container. Using one image, you can create 10, 20, 100,000 containers also. Sir, why to create multiple containers using single image? I want to run my application in multiple machines. That's why we will create multiple containers. Why to run application in the multiple machines? For load balancing.
Load balancing.
If I run my application in one container, all the requests will go to one container, burden will be increased. When burden is increased, then response will become slow. I want people to access my application quickly. My application should respond quickly. Then that's why we are going to run our application in multiple containers. We can increase the count, we can decrease the count. So in the real time, who will create the containers for the images by using images? Are we going to create the containers manually or we will automate containers creation in the real time?
Automatically.
Container management will be available, guys. Create the container, stop the container, start the container, increase the count of the containers, decrease the count of the containers. That is called orchestration. Who is responsible for orchestration in the project now?
Kubernetes.
Kubernetes.
So you got the difference. What is Docker and what is Kubernetes? Where we will use Docker, where we will use Kubernetes. Docker is used for containerization. Kubernetes is used for orchestration. Are you clear with my point? Now in the real time, This complete process will be automated with the CI/CD pipelines. How the CI/CD pipeline will come into picture? Developers are writing the code. They will store the code into GitHub. Then we need to take the code from the GitHub. We need to build that code by using Maven. Then we need to create a Docker image for the application. That a Docker image we need to run. Then container will be created. Instead of we are doing that work manually, we will tell all this information to Jenkins. Whenever code is modified in the GitHub, Jenkins will take the code from the GitHub. Jenkins will build the code by using Maven. Then Jenkins will create the Docker image. Jenkins will give the Docker image to Kubernetes. Then what Kubernetes will do?
Managing the containers.
Jenkins will give the Docker image to Kubernetes. Then Kubernetes will run the Docker image. Generally, we will run the Docker image manually to create the container for practice. But in the real time, in the real project implementation, we don't run the Docker images manually. We will give the Docker image to Kubernetes. And Kubernetes will run the Docker image. Then Kubernetes will create the containers. How many containers should be created? We will tell to Kubernetes. Hey Kubernetes, this is my Docker image. Create 20 containers. Then Kubernetes will create the 20 containers further. Hey Kubernetes, 20 not sufficient. Make it 40. Then Kubernetes will run 40 containers for our application. That means our application will run in 40 machines. Why we will run our application in 40 machines? Same application in 40 machines? Load balance. Now, 40 is not required for us. Today, there is no traffic for our application. 40 is not required for us. Make it 20. Then Kubernetes will delete 20 containers. Will keep only 20 containers. Again, my load is increasing today. There is some offer in the website. More traffic is coming. Hey, Kubernetes, increase the containers. When it is not required, Kubernetes, delete the containers. Kubernetes is responsible for what?
Scaling the application.
Container management. Kubernetes is responsible for what?
Container.
That is called orchestration. You got the point? So nowadays, developers should know about containerization and orchestration. DevOps engineers should know containerization and orchestration. You got my point? So theoretically, I hope you are clear. What is Docker? Why to go with Docker? What is the containerization? And what is the Docker architecture? What is the Docker file? What is the Docker image? What is the Docker registry? And what is Docker container? And what is the execution flow in the real time? In the real time, project's deployment will happen like this. This is called CI/CD pipeline.
Sir, one doubt, sir.
Hello, sir. One doubt. So
Sir,
here in future, you said everything is automated, right? For the Docker creation and image execution and all. It is one time required for the code writing.
Sorry?
In future, everything it is coming picture to automation, right? For the running the Docker image and containers in the application.
Yes, sir. CI/CD pipeline creation. Yes, sir. It is a one-time process in the project. Once you automate everything, we will reuse the same thing whenever there is a code change. We will run the job, and the job will process all these things. We will automate this. That is operations duty. DevOps engineer will automate all this work.
Okay, sir.
What DevOps people will do in the project? They will set up the GitHub repositories for us. They will set up the Jenkins servers for us. They will set up the Docker server. They will set up the Kubernetes cluster. They will write the CI/CD pipeline. That CI/CD pipeline, they will write the steps, take the code, build the image, push the image, and create the container. And they will monitor how Kubernetes is running, how Docker is running, how Jenkins is running, how GitHub is working, how the repository is available, what are the permissions available for the repository. All the infrastructure management will be taken care by DevOps team. You got it. Once the DevOps team is automated everything, tomorrow when there is a code change in the project, you can go to the Jenkins and you will click a button. Then Jenkins will perform all this process. Whenever there is a problem in the Jenkins, suppose Jenkins is not working as expected, pipeline is not working as expected, then that is infrastructure problem. Right? Then DevOps team will go and check why Jenkins is not working. They will find out the issue. They will fix the issue. Suppose if the issue is with the code, then developer should fix the issue. If your issue is there with the Kubernetes server, then DevOps team will fix the issue. Both the developers and the DevOps team will work collaboratively. That is called DevOps, development plus operations. You got it?
Yeah, clear, sir.
Good, perfect. What is the difference between why Maven is required and why Docker is required? What is the role of Maven? What is the role of Docker?
Maven is used
libraries.
For the library, whereas Docker is used to set up the
Maven is responsible to download the libraries to develop the code. Maven is responsible to download the libraries which are used to develop the code. Okay. Next one. Docker is going to download the dependencies which are used to execute the application. You got the difference? Perfect. Okay. So theoretically, we are clear. Now let me.
Sir, one doubt, sir. Sir, one doubt.
Guys, it is going like a doubts clarification session only. Okay, so many doubts. Once we complete the practical, then you will get the clarity. Then you can ask if your doubt is not clarified. Okay?
Okay, sir.
Good. Now I'm going to install Docker software in my Linux machine. You can install the Docker in the Windows also. You can install the Docker in the Linux also. But why I am preferring Linux? In the real time, we don't use Windows machines for application execution. Windows is used only for the project development purpose, not for the deployment purpose. The deployments will happen in the Linux machine. How to install Docker software in the Linux machine? The first step, I will create one Linux machine in the AWS cloud. Okay. Then I will connect with that Linux machine by using SSH client. Then I need to install the Docker software. To install the Docker software, I am giving some Linux commands. Okay. These three commands will help you to install the Docker. This command is used to give the permission for the EC2 user to run the Docker commands. Then I will restart this. I will log out from the machine and I will log in. Then I will see Docker is available or not. So these are the commands that we are going to use to set up the Docker in the Linux machine. Let me go to my AWS account and let me log in into AWS account. Okay. Go to AWS cloud, log in into AWS cloud. Let me give my credentials. Okay. It is asking me to set the MFA device to make my application, to make it more secure. Let me add authentication for my account, guys. Google Authenticator app I am going to use. One minute, guys. It is asking me multi-factor authentication for my AWS account. Let me set up with Google Authenticator. Google Authenticator app I am downloading in the mobile. By using that, I will set up authentication for my account. Extra security it is providing. Okay. Fine. With this, I am able to set up multi-factor authentication for my AWS account. So in the AWS, there is a service called EC2 service is available. By using this EC2, I will set up one virtual machine in the AWS cloud. So let me go to the EC2 dashboard, then click on launch instance, and I will create one machine. Launch instance, go to here, let me give the name for the machine. I'm giving the name as a Docker server. This machine I'm using as a Docker machine. So I'm giving the name as Docker server. Amazon Linux I'm using. T2 micro free tier machine. Key pair I need to select for this machine. I'm giving the key pair for this. Let me check what are the key pairs available in my system. Okay, AWS lab is available. Yes, let me select AWS lab. Then SSH traffic is allowing by default. Click on launch. So with this, I'm able to launch one Linux machine in the AWS cloud. Now I will connect with this Linux machine by using git bash SSH client. Go to the location. Here my PEM file is available. I'm waiting for the machine to be up and running. Docker server instances running. Yes, my machine is running now. This is public IP of my machine, which is used to access the machine. Click on connect option. Then SSH command is available to connect. Go to the PEM file location. Open this PEM file. This is what I told you yesterday. Who are attending this class, some basic knowledge of Linux is required. So the Linux videos are already there in our YouTube channel. I will share those. Okay, so close this, open git bash. I will connect with this machine by using git bash. Prerequisite for this course, basics of Linux. That's it. Yeah. So I'm connecting to this machine, SSH command. Yes, connected successfully. After connecting to this machine, now I will check docker-v. Docker is available in this machine. The Docker is not available in this machine, guys.
Not available.
Not available.
Docker-v, it is saying that Docker command is not available. That means Docker software is not available. Let me install the Docker. Sudo yum install docker-v. It is going to download and install Docker software in this Linux machine. Yes, Docker is installed successfully. Let me start the Docker server. Sudo service Docker start. Yes, with this, Docker is started. Then in order to access Docker as a EC2 user, I'm adding user to the group. So in the Linux classes, I explained user management, how to add the user to the group. Sudo user mode, add to the group. The group name is Docker. The username is EC2-user. So with this command, I'm adding this EC2 user to the Docker group. Now let me exit from the machine. I logged out from the machine and I'm connecting back to the machine. Okay. Then let us verify docker-v. Now can you see Docker is available in the machine or not? Now can you see Docker is available in this machine or not?
Yes, yes.
Yes.
Docker is available. Docker-v. So in order to set up the Docker, what commands we need to execute? I created one Linux machine in the AWS cloud. I connected with that Linux machine and I have executed these commands to install the Docker. I added user to the Docker group and I exited from the machine and I have executed docker-v. So with this, I'm able to set up the Docker successfully in this machine. So some people who are new to this course, who don't know how to do the Docker setup, how to create the Linux machine. For them, if you go to Ashok IT YouTube channel, the videos here, there is a video, 2 minutes video, how to do the AWS account setup for free of cost. Within 2 minutes, you can create the account in the AWS cloud. This video is available. And if you go to my playlist course here, in my playlist, Linux basic concepts. Linux basic concepts I have added. I think 4 videos available here. In this video, I have explained how to create a Linux machine, how to connect with the Linux machine, basic Linux commands I have explained. Yesterday, I told you I will share the basic commands of Linux, right? This is a playlist which is available in the Ashok IT YouTube channel. So if you go through these 4 videos of Linux, then easily you will be able to understand how to do this setup in the Linux machine. Okay, with this, Docker setup is completed. So in the Linux machine, I have installed Docker, guys. Then I am able to see docker-v. We are good. Now, once the Docker is available, directly I am not going to write the Docker file, guys. Actually, in the Docker architecture, if you want to work with the Docker file is required. By using the Docker file, we will create the Docker image. Using the Docker image, we will run the Docker containers. But now, I will not write the Docker file directly. Okay. First, I will show you how to see the images how to create the containers, that part I'm going to explain. So basic Docker commands we are going to understand. Basic Docker commands we are going to understand. So here there is a command called Docker images command is available. Docker images. What is the purpose of Docker images? Docker images command is used to display what all the images available in our system. So this is a new machine I have created. Just now I installed Docker in front of you. Is there any image available or there is no image available?
There is no image.
No image.
In my machine, images are available or images are not available?
Not available.
Images are
Not
not
available.
available.
Not
How to
available.
create an image? How to create an image?
We need
Using
to
Docker file.
connect with the Docker hub.
File is used.
Why need to create the image? To run the container. To
Right.
run the container, we need to create an image. To create an image, file is required. But do we know how to write the Docker file? We are beginners in the Docker, right? Do
Don't
we
know.
know how to write the Docker file?
No, don't know.
Write the Docker file?
Not yet.
We
We
don't know.
don't know.
We don't know. So then what I can do here?
We
Can
need
we
to
download the images which are already available in the Docker Hub?
Yes.
Somebody
Docker
already
hub.
created the Docker images in the stored in the Docker Hub. Can we download those Docker images?
Yes.
Yes or no?
Yes,
So
sir.
once we know how to write the Docker file, then we will write the file, we will create the image, we will play with the image. But today, our first practical session, if I teach Docker file directly, you may get confused. You may get confused. So in the next session, we will understand how to write the Docker file on our own. But today, I will not write the Docker file. What I will do is, I will download the Docker images from the Docker Hub. Docker, what is Docker Hub, guys? What is the meaning of Docker Hub?
Docker hub is already
Input
existing
image
images will
Images
be
stored in
uploaded
the
in the
Docker Hub.
It is a registry where the images are available. So many people will create the images, will store in the Docker Hub. I also have a Docker Hub account. I stored my images in the Docker Hub. Okay, hub.docker.com. So you can create one account in the Docker Hub in order to store your images. Okay, so some public images available, some private images will be available. Login.docker.com. You can go to Docker website. You can go to Docker Hub here. Once you go to Docker Hub container image library app containerization. Go to this website hub.docker.com. Here you can create the account to store your images. To store your images, you can create the account. Okay, develop faster, run anywhere. You can run your application anywhere by using this Docker. Docker official images available. Search Docker Hub. So see here, Docker official images are available. So product images are available. You can check the images. So how many images are available here? How many images are available here?
10,000.
10,000.
10,000 images are available. For example, I want to run Jenkins server. I want to set up Jenkins server. You no need to install Jenkins manually. For the Jenkins software, there is a Docker image already. Okay, you just type Jenkins here. Docker will tell you Jenkins image. If you use this image, if you run this image, Jenkins software will be available for you. How many people downloaded? How many people downloaded Jenkins image?
1 billion plus.
1 billion plus.
1 billion.
1 billion plus.
1 billion people. That means I want to set up, listen. 1 billion. I want to set up a Jenkins machine. I want a Jenkins server. Instead of downloading and installing the Jenkins manually, I will tell to Docker, hey Docker, download the Jenkins for me. Then Docker will give the Jenkins for you. You can run the Jenkins. For example, in my machine, I want to run Java. Okay, search for Java. Java Docker image is available. 100 people download. How many people downloaded Java? 100
100
100
million.
million.
100 million plus. For example, for my application, MySQL database is required. For MySQL, there is a Docker image. 1 billion people downloaded MySQL Docker image to run the MySQL database. You got my point? So these all are the public images which are available in Docker Hub. You can download those images and you can run those images. Now, if you want to store your images, then you can create account in the Docker Hub, hub.docker.com. This is called Docker registry. I already have my account in the Docker Hub. I'm trying to log in into my Docker Hub account. Okay, let me log in into Docker Hub. In my Docker Hub account, in my Docker registry, my Docker images are available. So these all are my Docker images which are available in my Docker Hub account. Like this, you can create one account in the Docker Hub and you can store your images also. Now let me go to my images here. So I will show you my images which are available. Okay. So there is one image I created, Ashok IT Spring Boot REST API, almost 3 years back. I created one Docker image and I stored it into my Docker Hub. How many people downloaded that image, guys?
70,000.
There is one Spring Boot application. I have Dockerized that Spring Boot application. I have stored it into my Docker Hub account. 70,000 people downloaded my Docker image. So they will run my Docker image. Now, this Docker image is public. You can download and you can run that image. Right. So here in my machine, is there any Docker image is available currently in my machine? Docker images are not available now.
Not available.
Docker images available or Docker images not available? Docker images not available. Now, how to download the image? To download the image, we will use a command called docker pull command. First one, Docker images command. What is the purpose of Docker images? To display Docker images which are available in our system. So when I execute a command, Docker images, I'm not getting any output. That means I don't have any image. In my system, there are no images available. Either I need to create the image or I need to download the image. How to download the image? Okay, to download the image, we need to use a command called docker pull command. What is the command, guys? Docker pull. Then you need to specify image name. You need to specify image name. So what is my Docker image name available here? Ashok IT / Spring Boot REST API. This is my image name, guys. This is my image name. So when I take this image name, Docker pull Ashok IT / Spring Boot REST API. Docker pull my image name, Ashok IT / Spring Boot REST API. I will copy this command and I will execute it. Docker pull space my image name, paste it. Okay, now execute. What is happening now? My Docker in this machine, Docker is installed. Then what this Docker is doing? This Docker is connected to Docker Hub and it is downloading my Docker image from the Docker Hub. That Docker Hub is a Docker registry. Once the image is downloaded, let me check it. Docker images. Now can you see the image is available in my system now? 2 years back I have created this image. 2 years back I created this image. The Docker image size is 178 MB. That is the size of my Docker image. I'm able to download the Docker image from the Docker Hub. So now can you tell me what is the purpose of Docker pull command? Can you please tell me what is the purpose of Docker pull command?
Download the Docker image from Docker Hub.
Yes. Download the Docker image from the Docker Hub. It is used to download Docker image from the Docker Hub. Okay. Suppose if you want to delete the Docker image from your machine, then Docker RMI remove image. By using image ID or by using image name, you can delete the Docker image from your system, not from the Docker Hub. So in my system, I downloaded. Now I don't want that. Okay. I downloaded this Docker image in my system, Docker images command. Okay. This is name of my image. This is my image ID. Now I want to delete the image. How to delete? Docker RMI either image ID or image name. Either image ID, image name, Docker RMI. The image is deleted. After deleting the image, now execute Docker images command. Is there any image available? Image is not available.
Not available.
Why not available? It is deleted. Now can I download once again? What is the command to download once again? Docker
Docker pull image name.
Docker pull image name. It is downloading the image again. Now, if I run this image, then container will be created. If I run the image, then container will be created. Are you clear with these three commands now? Docker images command, Docker pull command, Docker RMI command. What is the purpose of RMI? Remove the Docker image. Docker pull to download the image. Docker images to display the images available in our system. Okay. How to run the image? To run the image, we will use Docker run command, as I have shown you. Once you have the image, you can run. When you run the image, container will be created. Okay. So what is the command? Docker run command. For this command, you can give either image ID or image name. Then what will happen? It is used to create or run Docker container. Once your image is available, you can run the image. When you run the image, then container will be created. What is the meaning of container? What is the meaning of container?
Where application is executed.
The container is
Where the
Virtual machine.
Linux
Linux virtual
Container is
machine
a
application
virtual
is
machine.
executed.
where our application is getting executed, you can see that is a container. Container is used to run the application. Now here, first before creating a container, I want to see, is there any container is already running in my machine? Okay, Docker PS. Docker PS. Docker PS is a command which is used to display, is there any container which is already running in your machine? What is the purpose of Docker PS command? Docker PS command is used to display running Docker containers in our machine. In our machine, Docker is installed. Is there any container is running? That I can check by using Docker PS command. So containers are running. Is there any container in the running state? Containers are not in the running state now. No. And I want to check, is there any container which is stopped, not running? Container is there, but which is not running. PS-A. It will display stopped containers. Just PS will display running containers. PS-A will display stopped containers. Both running containers plus stopped containers also it will display. Docker PS, which is going to display only running Docker containers. I want to display running containers plus stopped containers also. Any container which is stopped I want to see. Then we can go with the Docker PS-A command. Docker PS-A command. Are you clear with my point? What is the purpose of Docker images command? Come on.
to display the Docker images available in our system.
Yes, it is used to display Docker images which are available in our system. What is the purpose of Docker pull?
To download the
Docker image from Docker Hub.
What is Docker Hub?
Docker Hub is
It's a registry where the images are
Where
available.
Docker images is stored.
Yes, Docker Hub is a registry where the images are available. Where the images are available. Okay, what is Docker RMI?
Remove command for
Remove the Docker
it will
images
remove all
from
the
the
images from
virtual
the
machine.
machine.
From our system. What is the Docker run command?
Run the
it
Docker
will create the Docker
image
or image
container.
ID.
Docker container.
Based on the Docker image, you can run the Docker container. What is a Docker container?
It is a virtual
It is the Linux virtual machine where application is executed.
Yes, that is a container, nothing but a machine in which our application is going to execute. What is Docker PS?
Display
display running the
Display the
Docker
running
containers.
Docker container.
In our machine, what all the containers are running, we can check. In our machine, what all the containers are running, we can check by using docker ps command. What is the docker ps-a?
You show the running containers as well
In
as
our
Together
mission,
in the
what are
stop
the running
container.
containers and stopped containers
Yes, in our
should be
machine,
shown.
what are the running containers and stopped containers we can see. Suppose my container is running, guys. I want to stop the container. Okay, docker stop container ID, which is used to stop running docker container. Suppose my container is already stopped. I want to start the container which is in the stopped state. Docker start command, which is used to start the container. Container is running, I can stop it. Container stopped, I can start it. Suppose I want to delete the container, then we can go with the docker rm command. What is the purpose of rm? And interviewer will ask you, what is the docker rm and what is the docker rmi? What is the difference between rm and rmi?
RM will delete the docker container.
RMI delete the Docker, removing the Docker images,
Yes.
and RMN removing the Docker container.
To delete the docker image. Okay, rm to delete the docker container. To delete docker container. Suppose in my system, so many containers are already stopped. Okay, containers are stopped. There are some images which I am not using, unnecessarily memory wasting in my machine. I want to delete all the stopped containers, unused images from my system. There is an image. Am I using this image or I'm not using this image? I'm not using. So like this, there are so many images available, so many containers available, which I am not using, which are not running, which I am not using. Then I want to delete them. With a single command, we can delete all of them to free up the memory. To free up the memory by deleting stopped containers, unused images, there is a command called docker system prune -a. Can you read the command now?
Docker system prune -a.
Prune -a, nothing but you remove unwanted data. Now, can you see what it is saying?
Warning, this will remove stopped containers.
This will remove all stopped containers, all networks not used by at least one container, all images without at least one container associated to them, and all the build cache. Everything will be deleted. Are you sure you want to continue? Yes, boss. Yes, total reclaimed space 178 MB memory it is saved. Okay, what is the command we used for that? Docker system prune -a. Docker system prune -a, which is used to delete stopped containers, unused images, and build cache. Everything will be deleted when we go for this docker system prune -a command. Are you clear with my point?
Yeah.
Very good. So read the commands again. In the interview, they will ask you these commands only, guys.
Docker images, Docker pull, then after the pull, the Docker hub, what we will be copy that ID we need to give to download Docker image from the Docker hub. Docker RMI is using for command to delete the Docker image. Then Docker run, then the image ID we will give to create or run Docker containers. Docker ps command to using for to display running Docker containers. Docker ps space -a to display running and stopped containers. It will be show. Docker stop, then container ID. If we are giving, then it will be a stop the running Docker container. To start the Docker, we need to give the command docker start space container ID to start Docker containers, which is the stopped state. Docker rm command will be using for removing the container. The difference between Docker rm and RMI is having a difference. RM will be using for removing the container. RMI command we will be using for removing the image. For delete stopped containers or unused images or build cache, we need to run the command docker space system space prune-a. It will be clearing the cache and stopped containers, unused images.
Very good, sir. Good job. Guys, all of you, clear with the commands now?
Yes, yes, yes.
Yes. Now,
Yes.
observe. Go to this machine in which Docker is available. Guys, in which machine you install Docker, that machine is called as host machine. In which machine Docker is available, that machine is called host machine. Now I have taken one Linux machine in the AWS cloud. In that machine, I installed Docker software. Okay. Now I want to download one image and I want to run the image, Docker images. Currently, any image is available or images are not available now?
No,
No
there is
images.
Images available or
Not
images not
No,
available?
no, there is no images.
There is no image. Now I will download one image. Observe carefully. Docker
Full
pull
image name.
hello world. What is the name of the image, guys?
Hello world.
Hello world.
Just for testing purpose, in our machine, Docker is working as expected or not. In order to test it, we are going to use a hello world image. Docker pull hello world. Where the hello world image available?
Docker Hub.
Docker Hub.
Docker Hub.
Docker Hub, Docker registry. That is a public image I downloaded. You see here, using default type, pulling from library hello world, pull complete, downloaded a image called hello world from the docker.io library. Hello world image is downloaded. Okay, now verify Docker images. Now can you see hello world image is available or not? So with
Yes,
this, can I say I'm able to
Yes.
download one image called hello world? Yes or no?
Yes.
Yes.
Yeah.
What is the size of the image?
13.3 KB.
13.3 KB.
Size is available. So this is the name of the image and this is the ID of the image. Now I want to run the image. So that container will be created. Docker run. Either you can use name of the image or you can use image. Docker run image. What is the meaning of Docker run?
Which is going to create the
To run
container.
the
Create the container and run them.
Container, execute. Now, when I execute Docker run hello world, can you read this command, guys? Can you read this, guys?
There are multiple images in the Docker Hub for Hello World. Which one it will identify and pull?
Latest.
That is it.
Based on the tag name. Can you guys read that output?
Yeah, hello from Docker. This message shows that your installation appears to be working correctly. To generate this message, Docker took the following steps. First one, the Docker client contacted the Docker daemon. The Docker daemon pulled the Hello World image from the Docker Hub. AMD 64. Third one, the Docker daemon created a new container from that image, which runs the executable that produces the output you are currently reading. The Docker daemon streamed that output to the Docker client, which sent it to your
Yes, that
terminal.
means how this output we are getting, they are explaining the process.
Yeah, okay.
Whenever you execute the Docker run hello world is a image where in that image, what is there? Just this message is printing. Okay. So what they are saying, hello world from Docker. Boss, if you are getting this hello from Docker, that means in your system, Docker is working correctly. So in your system, you installed Docker, you are trying to run the Docker images. Docker is working perfectly in your system. What happened internally? To generate this message, Docker software has done following steps. Docker client contacted the Docker daemon. Docker client nothing but Docker engine. In our machine, Docker software is installed. That Docker software internally will talk to one more component called Docker daemon. Daemon is nothing but a background thread. Okay, the Docker daemon pull this Docker image from the Docker Hub. The Docker daemon created a container from this image. Whatever the image we downloaded, with this image, it created a container. That container is providing a output that currently you are reading. Whatever output you are seeing, that output is coming from the container. Then Docker daemon stream it that output to the Docker software. Then it is printing that output on the terminal. So this is the process which happened in the background. So what I want to show you is how to run the Docker image. So I run one image called hello world. Then I got a message hello from Docker. This message shows that your installation appears to be working correctly. That means Docker is working correctly. Now let me check Docker PS. What is the meaning of Docker PS?
Container is created on the
Containers which are running. Is there any container which is running?
There's no container.
Now I go for Docker PS-A. What it is saying now?
Yeah, there is a
It running and stop
What is the meaning of
container.
PS-A?
stopped container.
Stop container.
Stop plus
That means
Unused container.
by using hello world image, I created a container. This is ID of the container. The container created 3 minutes ago and immediately that container stopped also. The container name is Piring Hamilton, some random name they are giving for the container, and that container is created. It given the output to our terminal and the container got stopped also. Docker PS, Docker PS-A. PS will display only running containers. PS-A will display running plus stopped containers also. Are you clear now? I want to delete the container. How can I do that?
Docker space
Docker
RM.
Docker
Docker RM image container ID.
Container ID or container name. Docker RM. Okay. Then what happened? Now go for Docker PS-A. Any stopped container available now?
No, deleted.
No.
Deleted. Okay. So if you want to test Docker is working successfully in your system or not, you can use Docker pull hello world. Then you can use Docker run hello world. Now one more point here, guys. Now can I execute a command called Docker system prune-a? What is the meaning of this?
Already, if any,
To display the cache
and stopped containers and the build cache.
and build cache and
Docker system prune-a. Okay, what is the purpose of this? It will remove.
it will delete the images.
It will remove all the networks which are not used. It will remove all the images and it will delete build cache. Yes, deleted. Deleted images. Fine. Now can you see, is there any image available in my system?
No.
Docker images available in the system or not available? Not available.
Not available.
Now observe. Docker run hello world. Image I have not downloaded. Directly I am running. What will happen?
it won't work.
It will download the image and run the.
Yes.
Earlier what I have done, I downloaded by using pull command, then I executed by using run command. But this time I'm not downloading. Directly I'm trying to run. Observe. What happened? Working or not working?
Working.
What is the meaning of that?
Pull the image from the Docker hub.
Whenever you execute run command with the image name, first it will check in your system, image is available or not. If image is available, directly it will run. If the image is not available, it will download and it will run the image. Are you clear with my point?
Yeah.
Are you clear with my point? So pulling the image is mandatory or it is optional?
Optional.
I think it's optional.
It is optional. That is the proof. If you have the image, if you run directly, it will run. If you run the image, when it is not available, it is downloading and it is running the image, right? Yes or no?
Yeah.
And directly we can execute this command, right? Docker run command instead
Directly
of
we
pull.
can execute this command. It will check in your system image is available or not.
Yeah.
Image is
If it
not
is-
available, it will download and it will run the image.
Got it.
You got my point? You got my point?
Yeah, clear.
Very good.
Which
Next
command
one.
mostly we will prefer in real time? So whether pull or run directly, we'll
First
run the
of all,
command.
in the real time, we don't run the containers manually.
Oh.
What I told you, how it will happen in the real time? Who will run the containers in the real time?
Kubernetes.
Pipeline, CI/CD pipeline.
Yes, it is pipeline. So we don't run these things. So this is just for showing you what is run command, how to run it. In the real time, we don't run the Docker images manually. We will give the Docker image to Kubernetes. Kubernetes will run that image.
Okay.
For validation, so we need to use these all the commands. Am I right?
This is just for checking purpose. That's it. Testing purpose.
Okay.
Yeah, I got it. Thank you.
Got my point?
Yeah. Got it. Thank you.
Yes. Very good. Very good. Fine, guys. Now, next one. Suppose I want to run my image. Ashok IT Spring Boot REST API image is available. So this is Spring Boot REST API, nothing but it is a Java application. To run the Java application, Java software is required. But in my system, Java software is available. Java software is not available.
Not available.
Not available.
Not available.
Not available. To run this Java application, do I need to install the Java or my Docker take care of that?
Docker will take care. From Docker, we can run the image.
I have a machine. In my machine, Docker software is installed. Docker engine is available. By using this Docker engine, I will download the Docker image and I will run the Docker image. Then my application will execute. So now I will download the Docker image. How to download the Docker image, guys? How to download?
Docker, then run an image name.
Before that, I'm going to show you
Docker run space, then
Docker images. Which image is available currently?
Hello world.
Okay, now I am executing Docker pull Ashok IT Spring Boot REST API. It is a Java based application, guys. Pull. It is downloading. Docker image is downloaded from the Docker Hub. It is public. You can also download. Okay.
Docker image.
Yes. Now go for Docker images. How many images available?
2 images.
Two images are available. Now I want to run my image. What will happen when I run my image?
It will
Create the container.
Container will be created.
What will happen when I run my
Container.
image?
Container is created where application is
I
executing.
think hello world is running now.
Container will be created, application will be executed. Application will be executed in my Linux machine or it will be executed in the container Linux machine.
Container
Linux.
How to run the image now?
Docker
run
space,
or image name or image ID.
Or
Image
ID.
name or image ID. This is a Java application. Do I have Java software in my system? Java software is not available.
Yes.
Not available.
Not available.
Do I need to install Java or it is not required?
Not required.
Not required.
Docker will installed.
Right. Good. You got the concept. Docker run image ID. Now check this. What is this, guys? Java
Spring application.
Java developers, you can see this. It is running my Spring Boot application. This Spring Boot application is running where?
Tomcat
What is the port number of the Tomcat?
9090.
9090. So Java, I installed Java or I did not install Java?
Not
We
installed.
not installed Java.
How this Spring Boot application is executed here?
Docker will install the Docker will install the application.
Docker image.
Docker downloaded and Docker. Here there is a problem. When you run Docker image like this, can you execute any other command in the terminal or we can't it is displaying the logs of the application. Can you execute any other command in the terminal or we can't execute any other command in the terminal?
You cannot perform any
Cannot execute any command.
Right, observe. If you run the image like this, application is started, application logs are printing, with the terminal is not available for executing further commands. Okay, so that's why what we will do is, instead of running the image like this, I will use like this, docker run -d. I will pass one argument called docker run -d space image ID. Then what happened? Container created in the detached mode, guys. -d represents a detached mode. What is the meaning of detached mode? Your terminal is free. Your terminal is free. Now you can execute the another command now. Docker ps. Yes, what is the meaning of docker ps?
Running
Running
Displaying the
container.
running container.
This is your
Running
image
container on
ID.
display.
This is your container ID, and application is executed. Okay, so now tell me, what is the difference between previous command and this command? Which is recommended?
Show the logs and we cannot perform any operation in the Linux.
But which one? This is recommended or this is recommended?
Detached mode is recommended.
Detached mode is recommended.
-d is recommended. Why -d is recommended?
So that we can use the
Open the
terminal.
detached
Detached
mode
mode.
in a
Detached
separate
mode.
console.
-d is recommended, which is used to access the terminal to execute other commands. Now, docker ps, it is displaying the container which is running. I want to see the container logs. Docker logs container ID. What is happening in the container? I want to check it. Docker logs container ID. Can you see the container logs? What is happening in the container now? Application is executed. Spring Boot application is running in the Tomcat server. Tomcat server running on the port number 9090. So we are able to see the logs of the container. How to see the container? When I'm running the container in the detached mode, then I'm seeing the containers which are running by using ps command. Then I'm seeing the logs of the container by using docker logs container ID. With this, we are able to see the logs of the container also. I hope you got the clarity how to run the Docker images in the detached mode. How to run the Docker images in the detached mode. I'm using Docker pull command, which will run the application, but you can't execute further commands. That is the reason I'm going to execute a command, Docker run -d, my image name I am giving. It will run the container in the Docker ps command. What is the purpose of Docker ps command? It will display running containers. Docker logs container ID. What is the purpose of Docker logs container ID, guys?
To show the logs for the
Displaying the Docker logs.
Display the logs of the container. So we are able to run our application in the machine, in the Docker, and we are able to run the Docker image, container created. But in my system, Java is installed or Java is not installed in my system.
Not installed.
Java is not installed. Then how this application is executed? Is it executing in my system? Is it executing in my system? And it is executing in the container system?
Container system.
Container system.
It is executing in the container system. But currently, can we access the application or we cannot access the application?
Not access the application.
No, we can't access the application. We cannot access the application. Why? Because I have a Linux machine. I know public IP of my Linux machine, but actually my application is not running in my machine. This is my Docker machine. This is my host machine. I know public IP, but application is not running in my machine. Application is running in the container. There is no relation between the container and my machine. If you want to access the application which is running in the container, then we need to establish the link between container machine and our host machine. The link we are going to establish by using a concept called port mapping. If you want to access the application directly, it is not possible. We need to establish the link between container is one machine and I am using one machine. In my machine, container machine is running. I need to create the link between container machine and my machine. So if I establish the link between container machine and my machine, then I can access. How to establish the link between container machine and my machine? By using port mapping. What is the port mapping? How to do the port mapping? That I will explain in the tomorrow class. Guys, this Saturday we have class. Tomorrow we have class at regular time.
Yes,
6
sir.
p.m. to 7:30 p.m. or 8 p.m. We have the regular class tomorrow. You got my point?
Yes, sir.
Yes,
Yes,
sir.
sir.
Yeah. So tomorrow we are going to talk about what is this port mapping and how to access our application. And the most important point, tomorrow I'm going to explain how to write this Docker file also. Tomorrow I will explain how to write this Docker file also. Today we discussed about mainly what is the Docker architecture and how to set up this Docker and how to work with the Docker command. Just within 15-20 minutes you can complete the practice. Tomorrow we are going to learn more about port mapping and we are going to learn about how to write the Docker file and how to create the Docker images. Those points we are going to learn in the tomorrow session.
Sir,
Is this
can you explain
clear?
again detach?
Sorry?
Can you explain again detach? I didn't get what is the detach.
Detach means your terminal will be available to execute the next command. Detached mode means it will run in the
Terminal
background.
will.
That's it.
Sir, guys are talking between. That's why please I'm unable to understand.
When
Please.
you run the command like this, docker run whatever the image is available. If you run the image here, then you can't run the other command in the terminal. So that's why we are going to run the docker image in the detached mode. When I use the detached mode, then your container will execute and you can execute the next commands in the same terminal. That is the meaning of detached mode. You got my point? Good. Fine, guys. So with this, we are clear with what is Docker, why to go for Docker, what is Docker architecture, how to set up Docker in the Linux machine, and how to work with the basic commands in the Docker, and how to run one real-world application by using Docker image, and how to check the logs of the container. Tomorrow, we will talk about how to access this application by using port mapping, and most important point, tomorrow we will learn how to write a Docker file. Okay, don't miss the tomorrow session, guys. It's very, 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 very important.
Sir, yesterday's backup video will be available or how it will be?
It's already uploaded in our WhatsApp channel. Yesterday, I have given WhatsApp channel link in the chat box. So if you join in our WhatsApp channel, you can access the yesterday's video. Okay. So the people who are joining for this, so tomorrow you can complete your enrollment to get the class notes access and class videos access. Okay. I have given channel link in the chat box, guys. People who want to access the backup videos, please join in that WhatsApp channel.
And in the class notes, Docker notes, yesterday's class you had talked about contents of all the topics covered, like
That
the
is there in the website
Kubernetes.
also, sir. That is the syllabus document is there in the website also.
Okay, that was
Sir,
not in the
sorry,
notes.
sir. I disconnected while you explaining the detach.